Welcome to Isizulu Tutoring. Kusase uYuPeter Foslorus. Nginonisa momentum grade 12. Momentum ke iyini? By definition momentum we define uthi momentum is the product of an object's mass and its velocity. So by definition, momentum is a product of an object's mass and its velocity. Isho ukuthini ke lento? Mawuzokhumbula kahle, mabethi into is a product, basho ukuthi into etholakale ngokuthi ku times we. Remember, isum siyithola mas-adda, i-difference siyithola mas-minus from i-maths, and then i-quotient siyithola mas-divide, angazi ukuthi ubhalwa kanjani quotient, and then i-product siyithola mas-times. So njengoba bethi bona momentum is the product, kusho ukuthi momentum into oyithola ma-times ini ke i-mass ye-object nani futhi ne-velocity ye-object. So ukuze uthole i-momentum kumele uthathe i-mass ye-object uyi-multiply ne-velocity ye-object. Yikho bethi momentum is a product of an object's mass and its velocity. Momentum is small letter p and then equals m times v. Okuwukuthi ke momentum is mv. M times v is mv. Eyini ku-p? A momentum, remember, sithe momentum is small letter p, and then mass yini, so m yini, mass of an object, and then v yini, the velocity of an object. Remember, mass is measured in kilograms ku paper 1, and then velocity is measured in meters per second. So mangithatha u-kg ngimtimes no meters per second ngizothola ama-unit we-momentum oku-kg times meters per second. So i-momentum is measured in kilograms meters per second, i-mass is measured in kilograms, and then i-velocity is measured in meters per second. Ama-SI units lawa we-mass ku-paper 1, ama-SI units lawa we-velocity ku-paper 1. So make sure ukuthi i-mass yakho is always in kilograms, i-velocity yakho is always in meters per second uma ukuthi uzocalculate i-momentum. Now, mawuyicabangisisa kahle njengoba i-momentum kuwukuthi ngithatha i-mass ye-object ngiyi-times ne-velocity, kusho ukuthi i-momentum idepende kwi-velocity really, because awuyicabange nje wena ufike uhambe mhlambe ngevelocity ewu-2 meters per second, mhlambe uthunyiwe bese yavela umuntu omdala ekuthumile, ye wena why uhamba kancane ngikuthumile, bese uyaqala uyagijima. So the time usahamba kancane i-velocity yakho ibincane, obekwenza ukuthi i-momentum yakho ibe ncane. Kathi esekuthethisile umuntu omdala wagijima, isizoba nkulu i-velocity yakho bese na-momentum yakho iba nkulu. Angazi noma niyangithola. I-mass yakho will remain the same. Ukuthi uthethisiwe noma uthethiswanga, i-mass yakho uma ukuthi u-56 kilograms izoba u-56 kilograms. So kubaluleke kakhulu ukuthi sazi ukuthi i-momentum idepende kwi-velocity. That's why in simple terms bethi i-momentum is an object in motion. Why? Because it depends on emotion. If emotion is fast, kusho ukuthi momentum izoba nkulu. Ngizama ukuthi if the velocity is high, for example, let's say sino-object ewu-3 kg i-mass yayo. If i-object ku-3 kg i-mass yayo bese ihamba ngo-5 meters per second, izoba ne-momentum ewubani ewu-15 kg meters per second. The very same object mangathiwa isihamba ngo-10 meters per second, isizoba ne-momentum ewubani 5 times 10 oku-30 kg meters per second. So i-momentum idependa kwini? Kwi-velocity. Let's say the very same object manje isihamba ngobani ngo-0 meters per second, okusho ukuthi i-at rest noma i-stationary ayihambi, kuzoba ubani i-momentum 3 times 0 kuzoba u-0 kg meters per second. So i-momentum ngempela idepende kwi-velocity ye-object. I-velocity mayinkulu, i-momentum izoba nkulu, i-velocity mayincane, i-momentum izoba ncane, i-velocity mayu-0, i-momentum izoba u-0. Remember ukuthi i-velocity is a vector quantity. So njengoba i-velocity i-vector quantity, kusho ukuthi ngoba i-momentum idependile kwi-velocity nayo izoba i-vector quantity. Asiyibukeni ngaleyo ndlela, but that's not how you actually explain ukuthi why izoba i-vector quantity, but asiyibeke kanjalo. So i-momentum ngizama ukuthi mina i-vector quantity, momentum is a vector quantity. Sesibuyela kwa grade 11, grade 10, grade bani. Yini konje i-vector quantity? I-vector quantity is a physical quantity that has both magnitude and direction. So kusho ukuthi momentum nayo ine-magnitude okuwukuthi for example 30 kg meters per second. This whole thing is the magnitude, and any direction mhlambe ngaba ukuthi to the right, if go to the right kube u-down, if go down, u-up, if go up, whatever direction, if go whatever direction. I hope niyayithola leyo nto leyo. So i-momentum izoya ngokuthi-ke i-direction ye-velocity yona igcine ithini. Singenze nayi example ye momentum. Let's say bathi calculate momentum la bakunikeza ibhola, bathi ibhola liwu 2 kg imass yalo, and then li travel to the right at 3 meters per second. Bese bethi calculate the momentum of the ball. Okay, you collect data. Nginayo yini i-mass? Yes, nginayo i-mass ubani u-2 kg and ngihappy ngama-units wakhona. Nginayo i-velocity. Yes, nginayo i-velocity ubani u-3 meters per second. But every time mawudila nento eyi-vector, you need to take i-direction into consideration. Ngizama ukuthini? Lo 3 lona kungenzeka ebe positive futhi lo 3 kungenzeka ebe negative depending on how you choose i-direction. Mina-ke i-direction ngiyichoose kanje. Remember lento le esiyibiza nge-Cartesian plane, lento le eno x no y la. Lento le siyazi ukuthi lana ama-axes are positive. Ama-axes are positive lana khona ama-axes anjani a-negative manizokhumbula kahle kwi-Cartesian plane, and then lana ama-axes wethu anjani a-positive, lana ama-axes wethu anjani a-negative. So mina ngithini-ke? Mina ngithi i-object mayiya up ngithatha u-up as positive, maya to the right ngithatha to the right as positive, maya kwa-left ngithatha to the left as negative, maya down ngithatha u-down as negative. So ngizohlezi ngiyichoose kanjalo i-direction unless bethe kwi-exam ngingayikhethi kanjalo, kuzongiphoqa ukuthi ngiyikhethe ngendlela abathi ngiyikhethe ngayo. So niyabona ukuthi kule example engizama ukunenzela yona ku-right ukuthi ngingathi mina u-3 wami yes kumele ebe positive. Remember ngifuna ukucalculate in mina i-momentum. So i-unknown variable u-p. Formula lithini? P equals mv. Ubani mass? Sekulula, ngithatha kwi-data yami i-mass u-2 and then ubani u-v u-positive 3, and then 3 times 2 is 6 kg meters per second, and then i-direction izothini-ke? Remember ngithatha to the right as positive, and mangiworka out lento le i-calculator yami ngikhiphela inumber positive, kusho ukuthi i-direction egcina ifavekile to the right. Yiyo-ke i-momentum le inani, magnitude and direction, ngoba iyini? I-vector quantity. Niyibheke-ke leyo nto leyo. Ithi sithathe enye example futhi. Let's say sinemoto. Imoto iyahamba iya kwa-left ngo-4 meters per second. I-mass yemoto basinikezile u-50 kg. kumele scalculate i-momentum, bafuna ukuthi scalculate i-momentum. Okay, ngicollect i-data, nginayo m, yes nginayo m and ngihappy ngayo kuma-kilograms. Okay, ngiyamthatha 50 kg. Nginayo v, yes nginayo v, and 4 meters per second, but ngoba mina uthi to the left, uyayibona i-arrow ikhomba to the left, so ngithatha u-left as negative, kuzoba u-4, and then u-p ngifuna yena. Sengingakwazi uku-calculate i-momentum la, ngizothini? P equals mv, formula lo-calculate i-momentum. I-mass ubani? 50 kg, ngihappy ngaye. I-velocity ubani? -4, ngihappy ngaye. And then sengizothini? 50 times -4 kuba u-200 kg meters per second. Asiyishiki anti-negative if still ane-vector. Remember lo negative lo uzama ukuthini? Uzama ukuthi kahle left. So kumele siyibhale ngendlela e-right ke, singamshiye be-negative, sivele sithini? Therefore u-p wethu kuzoba u-200, sesiyibhala i-positive kg meters per second, bese siba no-left. Ususolvile-ke i-momentum. Singayikhohlwa-ke leyo nto leyo. But uma uyibhekisisa kahle lento ye-momentum, okay, I hope uyayi-understanda. Uyabona ukuthi kungenzeka ishintshe i-momentum because ne-velocity ingashintsha. Njengoba kade ngishilo ukuthi let's say uthunywe umuntu omdala, mhlawumbe une-mass ewu-50, i-mass yakho 50 kg. Ukuthumile umuntu omdala uhamba ngale velocity le ewu-2 meters per second. Usiyavela umuntu omdala uyakubona ukuthi ayohamba kancane, uyakuthethisa. Gijima wena, akusho ukuthi i-mass yakho ngeke isaba u-50, izoba u-50. But mayisethi gijima, i-velocity yakho ngeke isaba u-2, but kuzoba into something greater than u-2, let's say mhlawumbe u-8 meters per second. Okay, usuyagijima-ke ngoba uthethisiwe. Kwenzakaleni-ke? Let's calculate i-momentum yakho before bekuthethise. Let's calculate your momentum before bekuthethise, khona nizoyibona lento engikhuluma ngayo. Singa-collecta mhlawumbe i-data, i-mass yethu, okay, yiyo le data, sifuna i-momentum. P equals mv. I-mass ubani? 50 kg. I-velocity ubani? Let's say ubuya to the right. I-velocity +2 then. And then soba nobani? 100 kg meters per second, and then original direction okubani? To the right. Okay, it's helping ngale momentum le. This is your momentum initial before bekuthethise. So initial, and then momentum mase bekuthethisile usushintshe velocity, usuqala ugijima ngoba umzali ufuna ukuthi ugijime, kuzoba ubani? Kuzoba u50 times 8. I-velocity u8, usaya ku-same direction, uzogcina uthola ubani? 400 kg meters per second, same direction to the right. This is your momentum bani? Final. Okay, usuyabona how kusho ukuthi momentum iyakwazi ukushintsha. Ngamanye amazwi khona into okuthiwa i-change in momentum ye-object. Khona into okuthiwa i-change in momentum kwi-object esingakhuluma mhlampe ngayo. Maningi ngama-scenario engenza ukuthi i-momentum ishintshe. Iyo le ngiqeda ukisho, noma mhlambe let's say ukhahlela ibhola liya towards the wall. Let's say nayi example, mhlambe ukhahlela ibhola liya towards the wall. Let's say ibhola liya towards the wall, and then malifika kwi-wall, li-strike i-wall, and then li-bounce libuyele emuva. If mhlambe beliya ngo-5 meters per second towards the wall, selibuya mhlambe ngo-3 meters per second, isishintshile njalo i-momentum, i-mass yes ayikakashintshi. I-change in momentum kungaba into kanjalo, mhlambe another scenario esingabona khona i-change in momentum. Even nanoma imoto ishayisana, silindele ukuthi mayishayisana kube ne-change in momentum, ngoba ayikwazi imoto ukuhamba nge-velocity mhlambe ewu-300 kilometers per hour ishayisane nenye iqhubeke ihambe ngo-300 kilometers per hour, ku-unlikely lokho. So change kwi-physical science siyazi ukuthi change u-delta. So njengoba sikhuluma nge-change in momentum kusho ukuthi delta P. Okay, ngibhale lana change in momentum. Change in momentum. So masikhuluma nge-change sikhuluma ngo-delta, because sikhuluma nge-change in momentum shuthi delta p. Kusho ukuthini-ke? Remember, i-change in velocity is velocity final minus velocity initial. Siyifundile leyo nto kuma-lower grades. So nala kushuthi sinobani? Momentum final minus momentum initial. Remember, momentum is p. And then ubani lona? Momentum is mv, remember, minus mv. So if this is momentum final, kusho ukuthi u-mv final. Angikwazi kodwa ukufaka u-final kwi-mass ngoba i-mass izolokhu iyileyo nto leyo. I hope unothisile umzali uma ekuthuma ethi gijima ayishintshanga i-mass yakho, kushintsha i-velocity. So into engingafaka u-initial no-final kuyi-velocity, i-mass ngizoyiyeka kanjalo. Since ngithi mina i-mass iyafana ayishintshi, kusho ukuthi singayibona ngengqondo ye-math from le nto le ukuthi kusho ukuthi i-mass iyi-common factor. Ngingakwazi ukuyi-factor out i-mass as i-common factor, kusala u-vf minus vi. Iyo i-change in momentum lena, change in p. Ngijwayele ukusebenzisa leli formula-ke mina uma ngicalculate i-change in momentum. Kwi-exam bajwayele ukunikeza naleli formula leli kwi-formula sheet. Makufundwa-ke ey'koleni kuyashiwo ukuthi iformula libhale exactly ngendlela abakunikeze yona kwi-formula sheet. Ngizocela ukuthi nani nikwenze lokho makunganisindi ukuthi nilibhale njengoba linjalo kwi-formula sheet. But into eyi-one lena nalena ukuthi nje la sengikhiphe i-mass as a common factor. Ithi senze i-example ye-change in momentum nizobona ukuthi kuba into kanjani. But yiyo i-momentum sekuthi you decide on inakhunja by reading through i-statement. Usuzodecide ukuthi okay kushuthi nayi i-final mass, nayi initial mass. Ithi sithathe yona leya example leyana, nali ibhola liyahamba ngo-5 meters per second liya kwa right. Ibhola liwu-2 kg mass yalo, bese lifika la kwi-wall, li-strike i-wall and then li-bounce back. Lihamba manje ngobani? Ngo-3 meters per second. Sase uye kodwa u-2 kg. Okay, si-happy ngaleyo nto. So uma ukuthi liqala la ibhola liye kwa right, the initial velocity siyavumelana ukuthi ubani? U-5 meters per second or positive, and then the final velocity ubani? U-3 meters per second or negative kodwa ngoba isiya kwi-opposite direction kwa-left and sithatha u-left as u-negative, and then i-mass ubani? U-2 kg. Singakwazi ukuthi siyi-calculate i-change in momentum. Change in momentum equals m into vf minus vi. Ubani mass? Sengivele ngithatha khona la u-2 kg, ngihappy vele ama-kilograms. Final velocity u-3. Lo minus lo owe-formula lo engimfaka njengamanje, hhayi ukuthi ukuthi i-velocity negative. Uyabona njengoba ku-minus ngehla naye owe-formula bese ngithini-ke i-velocity elandelayo the initial ubani? Positive 5. Bese ngizothola-ke i-change in momentum ewu-negative 16 kg meters per second. But u-negative lona ungitshela nge-direction, uthi left kahle kahle. Therefore, change in p mawuzokhumbula kahle is 16 kg meters per second. Sengiyibhala iba positive bese ngithatha u-negative ngizombhala in words. Uyu-negative lo kahle kahle. Left. So uyitholile-ke i-change in momentum. I hope niyayithola leyo nto. Into ebaluleke kakhulu leyo ukuthi uyazi ukuthi iya-calculate-ke i-change in momentum, and ziningi izinto ey'nga-resulta to i-change in momentum. Kungaba yiwo lama-scenario awu-2 engiwabekile namanye-ke ama-scenario engiwabekile noma engingawabekanga, sorry, ngifuna ukuthi engingawabekanga. Njengoba bengishilo ukuthi enye i-scenario ye-change in momentum ukuthi mhlambe kungaba imoto lena ehambayo mhlambe iya lena, phinde kube futhi enye imoto lana ehambayo iya le. Lezi moto bese ziyashayisana la. So uma yishayisana le imoto zo-2, obviously velocity le moto ade ihamba ngayo ngeke isafana after ukushayisana, izohamba ngenye i-velocity. Kanjalo nale i-velocity ade ihamba ngayo before zishayisane ngeke isafana. So i-change in momentum ingenzeka lapho, into esiyilindele leyo. Khona into engifuna ukukhuluma ngayo-ke kuthiwa i-principle of conservation of linear momentum. Into uma bethi conserved basho ukuthi ayishintshi. Uzozwa ukuthi i-momentum noma i-linear momentum iba conserved uma kwenze njani. Okay, let's say sine scenario lapho khona kuza imoto ayikho ke normal le moto le bese ifika ishayisane. This is car A, this is car B. Car A is traveling to the right, car B is traveling to the left. Bese beyashayisana ke car A no car B la. Siyavumelana ukuthi car A une momentum yakhe before beshayisane. Car A futhi une momentum yakhe after beshayisene. Kanjalo na car B une momentum yakhe before beshayisane ebe ne momentum yakhe after beshayisene. I-momentum ka-A before beshayisane ngeke ifane ne-momentum ka-A mase beqeda ukushayisana no-B. Kanjalo i-momentum ka-B before eshayisane no-A ngeke ifane ne-momentum ka-B after ukushayisana. Ama-objects ma eshayisana njengoba wazi iy'moto ziyashayisana ihambe kancane zime. Ayivele nje ishayisane bese kuba ngathi akwenzakalanga lutho. Okay. Let's say siconsider lento yalezi imoto zo-2 as i-system e-isolated. Masithi i-system i-isolated sisho ukuthi awekho ama-external forces lana azo-interfere. Angazi noma niyayithola leyo nto le. So i-isolated system is a system whose net force is 0. Okay, if the system is isolated, the momentum of A, if the system is isolated, silindele ukuthi the momentum of A together with the momentum of B initially before beshayisana izolingana ne-momentum of A together with i-momentum ka-B mase beshayisene okusho ukuthi final. I hope niyayithola leyo nto. I-momentum ka-A yesizoshintsha, eka-B yesizoshintsha. But mawuthathe ka-A neka-B uyihlanganisa before zishayisane le imoto izofana nalapho uthathe ka-A neka-B uyihlanganisa after sezishayisene. That's if the system is isolated. Niyangithola. Kubalekile ukuthi ukwazi ke lokho. Le engikhuluma ngayo i-principle of conservation of linear momentum. Principle of conservation of linear momentum. Ithini? I-principle of conservation of linear momentum. It's in an isolated system, states in an isolated system. The total linear momentum remains constant. Principle of conservation of linear momentum. It's in an isolated system. The total linear momentum remains constant. Nali igama elibalekile the total. Kusho ukuthi momentum of object 1 plus the momentum of object 2 before is equals to the momentum of object 1 plus the momentum of object 2 after. Okay, kwi-number pattern sifundile ukuthi sum, remember total is sum. Sifundile ukuthi sum is denoted by sigma. So sigma P before equals sigma P after. Le nto engiqeda ukuyibhala le yiyo i-principle of conservation of linear momentum le mathematically. So sigma P before equals sigma P after. Kusho ukuthini ke lokho masingayi-expanda le equation lena kusho ukuthi P initial of object 1 plus P initial of object 2 equals P final of object 1 plus P final of object 2. Konje ubani P initial u-MVI of 1 mass 1 plus ubani P initial 2 u-MVI of object 2 mass 2. I hope niyayithola leyo nto le. U-P final 1 ubani u-MV u-P and then final of object 1 plus M v final of 2 object 2. Iyo principle of conservation of linear momentum le engiyibhalile. Now njengoba ehamba lama objects lawa anento okuthiwa i-kinetic energy, and an energy an object has due to its motion. So once i-object yaba in motion ine-kinetic energy. I-kinetic energy kuyenzeka-ke in an isolated system uthola ukuthi iba conserved. That's one scenario. Kuyenzeka futhi ingabi conserved. That's one scenario futhi. Sisazokhuluma-ke ngaleyo nto ukuthi kusuke kwenze njani uma i-conserved, kusuke kwenze njani uma ingekho conserved i-kinetic energy. But i-momentum izohlezi conserved if i-system is isolated. Khona into okuthiwa i-collision, ngisazosebenzisa kakhulu lelo gama. Khona into okuthiwa i-collision. I-collision is just an interaction between nje ama-object. So njengokushayisana kweyimoto kubizwa nge-collision. Mangathiwa ukha A uyahamba uzohlangana nokha B beshayisane, leyo nto ibizwa nge-collision. Mawukuthi ukha A lona bayadonsana nokha B bayalena, i-direction of motion iyale, bese kwenzeka le ntambo le ba-connectile ihlephuke. That's another scenario for i-collision. I-collision le intambo isihlephukile. I hope niyayithola leyo nto leyo. Enye futhi i-type of i-collision, let's say i-truck leli liyahamba liphethe i-box mhlambe linamathuluzi, bese leli box leli mayiqhubeka ihamba bese liyawa, i-collision futhi naleyo. So i-collision is an interaction ezo results to a change mhlambe in velocity. Angithi uyabona njengoba lo ezoshayisana nalo i-velocity yakhe izoshintsha, nekalo izoshintsha. Njengoba lo ehamba nalo bane velocity efanayo, but makuhlephuka intambo izo-velocity kalo izoshintsha, nekalo ngeke isafana nekalo. Kanjalo nala njengoba ihamba zowu-2, i-truck ne-toolbox zihamba nge-velocity efanayo, but mayisiwile i-toolbox sazi ukuthi izoma and then i-truck liqhubeke liyihambele lona. So i-collision into kanjalo. Kuyenzeka mhlambe kukhulunywe nangama, let's say mhlambe i-asteroid rock lena kwi-space iyahamba-ke mhlambe nge-velocity ehamba ngayo bese iyahlephuka, kuphuma i-piece A1 kuphume ne-piece A1, le piece ihambe mhlambe le piece iqhubekele, still i-collision leyo. I hope niyawabona ama-scenario we-collision. Into ebalulekile ngayo i-collision ukuthi sikwazi ukucalculate ama-velocities, i-initial velocity of one object noma i-final velocity of one object, noma yini kabangathi siyi-calculate using leyo application leyo. Ubona kanjani ukuthi sengikwelento le ye-collision? Ubona ngokuthi ube nama-objects awu-2 mhlambe bexoxa istory ukuthi okay kune-object 1 nalezi zinto lezi, kune-object 2 nalezi zinto, and then u-object 1 no-object 2 baya-interacta ngendlela ba-interacta ngayo, is ukushayisana noma ukwenze njani. Suyabona ngikulento ye-principle of conservation of linear momentum. Another thing-ke mawenze inakhonje physics paper 1 mabekustatisa i-principle noma whatever bathi i-state kanti leyo nto ine-formula, uhlala wazi ukuthi basuke bekunikeza i-hint yokuthi the very first calculation ozohlangana nayo sebenzisa i-formula layo leyo nto oqeda ukuyi-state. Let's say for example ku-number 1 bathi state the principle of conservation of linear momentum, bese uyayi-state in an isolated system the total linear momentum remains constant. Bese bethi ku-number 2 calculate the final velocity of the bullet mhlambe, let's say bekuyi-bullet nani. Usuyabona ngiqeda ukustate i-principle of conservation of linear momentum, okusho ukuthi kungenzeka ukucalculate i-velocity ye-bullet ngisebenzise lona leli formula lalento engiqeda ukuyi-state. Nihambe nayo-ke leyo nto throughout upaper 1 ningayikhohlwa. Khona ama-case-ke awu-3 engifuna ukukhuluma ngawo, 3 or 4 engifuna ukukhuluma ngawo kwi-collision bese senza i-example mhlambe. Remember uzofika ubhale mawubhale i-principle of conservation of linear momentum, siyadinga ukuyibona lento le uthi sigma p before equals sigma p after, and then uyayi-expanda. Ungayi-expanda ngey'ndlela ey'hlukeneke. Let's say indlela yokuqala mhlawumbe uzoba mv plus mv equals mv plus mv. Remember, mass 1 initial of 1, mass 2 initial of 2, mass 1 final of 1, mass 2 final of 2. If uyibhale kanjena kusho ukuthi ama objects lana objects amove separate before and after the collision. Angazi noma niyayithola leyo nto le. If ama objects amove separate before and after collision kusho ukuthi lona uzoba ne-mass yakhe ne-velocity yakhe, mass yakhe ne-velocity yakhe before bebe move separate. Even after une-mass yakhe ne-velocity yakhe, mass yakhe ne-velocity yakhe kusho ukuthi ayikho into common kubo. Kuyenzeka ke i-scenario thothi usubhale lento lena but mase uyi-expanda uzoyi-expanda kanje uthi vi m1 plus m2 and then uthini m1 vf1 plus m2 vf2. La kusuke kwenzakaleni ke ama objects asuke move as a unit before the collision. Asuke move together before the collision. So objects lana moved together before the collision and then they separated after. Why sitha move together? Uyabona ukuthi manje sesifactor out, uyabona ngathiwa uyafana, for example lo nalo singakwazi ukumkhipha as a common factor, simfactor out bese kuphuma into kanje, phuma into kanje. So yiyo into eyenzekile leyo. The only way ingenzeka leyo nto ukuthi zihambe together. Ama objects mayihamba together asuke ne velocity efanayo. So that's why siyikhipha as a common fact. And then another scenario kungaba ukuthi mhlambe ama objects emove together after the collision. Kusho ukuthi azoba ne common final velocity kube m1 lana plus m2. Kusho ukuthi 1 initial of 1, 2 initial of 2. I hope niyayithola leyo nto lana. Objects, okay, objects moved together after collision. Ibalekile lento ukuthi uyazi ukuze ungeze kuba nezinkinga mase kumele usolve. Mawukuthi awamuvanga together before and after izoba kanje. Mayimove together before izoba kanje. Mawukuthi amove together after izoba kanje i-equation yakho. After writing le equation le mase uyi-expanda usuzo simplify azoba kanje. Kuya depend ukuthi kwenzakaleni, usilalelisiseke istory. Ithi ngenze ama examples so that nizobona ukuthi ihamba kanjani ke lento le. Unikezwa nje i-scenario, ulalela i-scenario. Once waba nama objects awu2 uhlalwazi ukuthi okay ngizoba no sigma p before equals sigma p after, ngoba nginama objects awu2 a interactayo ukuthi sengikwi concept ye principle of conservation of linear momentum. Okay, let's say sine example lana i-object i-4 kg. Okay, i-object i-4 kg iyamuva ngo-2 meters per second to the right. Kune object i-3 kg iyamuva ngo-3 meters per second to the left. And then lama objects lawa, this is before bese after ukushayisana njengoba ubona ngathi azoshayisana. Mase eshayisene lama objects lawa should kube yiyo ke into eyenzakalayo lena. Sesilindele ukuthi u4 kg, say u4 kg lona 3 kg, silindele ukuthi u4 kg mhlambe eyelena and then lona uzoya le ngo 0.5 meters per second u4 kg and then i-velocity kalo asiyazi. Bengasho ukuthi calculate the velocity of the 3 kg ball after the collision. Usuyezwa ko kusho ukuthi ngilento ka sigma p before equals sigma p after. but ngiyathanda ukuthi ngicollect data. Ngicollecta kanjani ke data? Ngiyadecide ukuthi ubani kuzoba object 1 wami, ubani kuzoba object 2. Let's say object 1 u4 kg, kusho ukuthi mass 1 4 kg. The velocity lena u2 to the right is the initial velocity of 1, u2 positive ngoba ithi to the right. And then yini futhi enginayo ka1 or the final velocity of 1 enginayo negative 0.5. Remember to the left simthatha as negative, so negative 0.5 meters per second. Okay, bese ngisa collect data u2 kushuthi sekuyilo ka 3 kg. Imass ka2 ubani u3 kg. Wa-check ama-units. Maku ama-grams kuzomele udivide ngo-1000 kuze kuba ama-kilograms. Maku ama-kilometers per hour velocity kuzomele udivide ngo-3.6 ukuze kuba ama-meters per second. Okay, sinayo initial velocity ka-object 2 ubani u3 meters per second, but uya kwa-left kushuthi uzoba negative. And then the final velocity of 2 anginayo. Kushuthi i-question ibingathi calculate the final velocity of 3 kg block or ball. So thinike ahambe separate before and after mangwabheka. So izothi m1 vi1 plus, okay, ithi ngiyibhale kanje lento le. So izothi momentum ka1 kusho mv plus momentum ka2 umv. Momentum ka1 plus momentum ka2 u1 initial ka1 u2 initial ka2 u1 final ka1 u2 final ka2. Okay, sekulula ke manje sesenza substitution. Sesenza nje i-substitution. Imass 1 ubani sengiyothatha lapha kwi-data yami engiyicollecte kudala, imass of 4 kg m1 ngifaka u4. V initial of 1 positive 2. M2 ubani positive 3. Vi of 2 ubani negative 3. M1 ubani u4. Vf of 1 ubani negative 0.5. M of 2 ubani u3. Vf of 2 sifuna yena. So uyasolva ke la sekuyi-linear equation. Uma uwazi usolve for x linear equation ungakwazi ukuyisolva le question le. Uzoyisolva kanjani ke? Uzothatha lona wonke umenze calculating. Uyazi kuzophuma u8, phuma negative 9, ukuzogcina ku negative 1 equals to bese ushaya lo ecalculating. Obviously lo kuzomela ugcina umtranspose le kuzoba u2 kodwa lo o negative and then umtranspose ebuye ngapha. But ekugcineni kosuku udivide ngo3 ngapha nangapha. At the end of the day uzogcina uthola I final velocity of 2 0.33 meters per second. Ngoba iphume yaba positive kuzoba to the right. Ngoba sithatha right as positive. Iyo ke example le yama problems lawa we principle of conservation of linear momentum. Ithi ngenza example 2. Okay, na enye example. Sinikezwe i-object of mass 1.5 kilograms happy ngama units wakhona kilograms no 0.5 kilograms happy. Uyahamba 1.5 kilograms uya to the right ngo 5 meters per second, and then 0.5 kilograms stationary noma at rest umile, velocity yakhona 0 meters per second. After the collision kusho ukuthi u1.5 uhambe wayoshayisa u0.5. After the collision sibabona sebehamba bo2 to the right but abasitshelanga ivelocity yakhona. Kusho ukuthi bazothi sifune yona. Siyazi ke sicollect data. Mas collect data sithini ubani object 1. Let's say object 1 1.5. So mass of 1 is 1.5 kg. And then Vi of 1 ubani positive 5 meters per second. And then khona enye enginayo of 1, no, the final of 1 angiyazi. And then u2 a mass of 2 kushuthi kuzoba 0.5 kilograms. Vi of 2 is 0 meters per second. Vf of 2 naye futhi angimazi. So bazothi ngicalculate ke i-final velocity. But into engiyinotisayo ukuthi lo nalo bayafana, ungaze uyitshela ukuthi unama-unknown variables awu-2 no bahamba nge-common final velocity labantu baya kwa-right bowu-2 so kusho ukuthi sikuleya case leyana ezothini sigma p before equals sigma p after besithi mv plus mv but la kune-common final velocity kuzoba m1 plus m2 la no-1 initial of 1 u-2 initial of 2 I hope niyayithola u-m1 ubani kudala uyi-collectile idatha sekulula 1,5 initial of 1 positive 5 plus mass of 2 is 0,5 initial of 2 u-0 equals final esiyifunayo mass 1 ubani 1,5 plus mass 2 bani 0,5 so yazi kuzokwenza yonke lento ecalculating although le ku-0 vele but uzoyenza yonke lento ecalculating bese uthi divided by lento le bese uthola u-VF imethi ke leyo linear equation VF equals uzogcina uthola i-final velocity ewu-3,75 meters per second to the right ithi to the right ngoba sithola i-answer positive i-final answer I hope niyayithola leyo nto leyo into nje e-straightforward singenze i-example yokugcina and then sidlulele phambili okay na enye i-example yokugcina before bekuyitsheleli let's say yitsheleli i-rock so le rock lena kwenzekile ukuthi igcine ihlephuka enye piece bayihlephulile le rock lena it was traveling to the right at 6 meters per second it has a mass of 5 kg and then maybe bayidubula for example angazi but yahlephuka le rock lena enye piece kwaba u2 kilograms enye piece kwaba u3 kilograms u2 kilograms utravela to the left at 1,8 meters per second sebethi ke as calculated the final velocity of the second piece u3 kg piece so decide ke sino mass 1 let's say 2 kg and then the final of 1 ngicela ukubhala i-final ngizokhuluma khona manje nge-initial the final of 1 is 1,8 meters per second but on negative and then let's say object 2 lo object 2 mass of 2 kuzoba ubani 3 kg the final of u2 asinayo sifuna yona but into ozoyinotice ngo before ukuthi we only had one object ku before I hope niyayithola leyo nto le with velocity of 6 meters per second and the mass of 5 kg so masingathi thina sicalculator lona sizothi sigma p before equals sigma p after but eqinisweni lana we only have u-mv sine object eyi-1 ku before so asikho isidingo sokuthi ngithi object 1 plus object 2 no sine object eyi-1 before and then final ngino-1 final of 1 plus 2 final of 2 I hope niyayithola leyo nto le and then i-mass ubani 5 before and then nakho before siyambona la u6 equals to mass of 1 ubani u2 the initial velocity the final of 1 is 1,8 plus mass 2 ubani u3 final sifuna yena final of 2 singakwazi ukusolve la uzoshaya lona ushaya lona umtranspose kodwa lo ayibuya ngapha bese udivide ngo3 ngapha nangapha uzogcina uthole answer ewubani ewu11,2 uVF2 lo 11,2 meters per second ngoba iphume yaba positive kusho to the right I hope niyayithola leyo nto into ebaluleke kakhulu ukuthi niyazi leyo okunye kokumele ukwazi ukuthi kuyenza bethi calculate the magnitude of the velocity of the final velocity mabethe the magnitude asikho isidingo se direction bafuna the magnitude remember i vector vector quantity, the vector quantity has magnitude and direction. So mabebona calculate the magnitude ba specific bafuna lo kuyo leyo vector leyo bafuna only the magnitude abanendaba ne direction. I hope niyayithola leyo nto le. But mabethe nje calculate the velocity usuzokhumbula ukuthi velocity is a vector quantity, therefore ine magnitude and direction. Ama collisions ke njengoba ubona kunama scenario ahlukile, ama objects ahambe together after noma wahambanga together after, ama types of ama collisions lawo kunama types of collisions. Khona collision esithi elastic collision, bese kuba khona collision okuthiwa inelastic collision. Uyakhumbula ukuthi ngithe mina kwi-principle of conservation of linear momentum, in an isolated system the total linear momentum remains constant. So mawukuthi system isolated, i-momentum izohlezi i-constant. Ngase ngathi kodwa i-kinetic energy ingashintsha yona. So mawukuthi i-kinetic energy is conserved leyo collision ibizwa nge-elastic collision. So collision in which kinetic energy is conserved. Kusho ukuthi kinetic energy before, the sum of kinetic energy before is equals to the sum of the kinetic energy after. Sigma EK, kinetic energy is EK before, equals sigma EK after. Leyo collision isuke i-elastic ke mawukuthi i-kinetic energy before iyalingana ne-kinetic energy after, but the sum of kinetic energy before izolingana ne-sum of kinetic energy after. Ihinti ke ukuthi ubone ukuthi i-collision is elastic ukuthi ama objects separate after the collision, resulting in no loss in kinetic energy. Ihinti le ekutshelayo ukuthi okay, this collision is elastic because some objects are separate after the collision, sorry. Should my move together after the collision, then ihinti leyo yokuthi the collision is inelastic. Kusho ukuthi there was a loss in kinetic energy. Okay, ngisazobuya ke lapho. Khona collision okuthiwa inelastic collision, a collision in which kinetic energy is not conserved. Kubalulekile ukuthi ukwazi ukudefine i-elastic collision, kubalulekile ukuthi ukwazi ukudefine i-inelastic collision. Elastic collision is the collision in which kinetic energy is conserved, sorry. And then inelastic collision is the collision in which kinetic energy is not conserved. Buka kuleli gama leli lika elastic akekho nanoyi-1 u-n. Buka kuleli gama leli ka inelastic kuno n. Lo n thatha ngokuthi oka not conserved. So collision in which kinetic energy is not conserved. I hope niyayithola leyo nto le. Okay, kusho ukuthi izothi sigma EK before is not equals to sigma EK after. Iyo ke i-inelastic collision. Kusho ukuthi into ongabona ngayo ukuthi i-inelastic collision ungabona ngokuthini? Ihinti leyo ukuthi ama objects moved together after the collision, and then kinetic energy is lost, noma there's loss in kinetic energy. I hope niyayithola leyo nto le. Ungarely kakhulu ke kulento yokuthi amove together, therefore inakhunja inelastic collision, awamuvanga together, therefore elastic collision. Ungayithathi kanjalo, but hint yona le iyasebenza kakhulu. Ngithi ungayithathi kanjalo because kuyenzeka i-collision ibe perfect, ingabi perfectly elastic. Ibe elastic, yes, but ingabi perfectly elastic. But ayibalekile kakhulu leyo nto leyo. Ngizama ukusho nje so that sizo understand ukuthi awurely kakhulu kulento ka objects move together, objects separated, no. Now kwi-exam kuyenzeka bethi prove ukuthi i-collision elastic noma inelastic. Uprove kanjani ke? Ziwu-2 indlela zokuprova. Thi nginibonisa indlela yokuqala and then nginibonisa indlela yesi-2 yokuprove ukuthi i-collision elastic noma ayikho elastic. Okay, babethi prove ukuthi i-collision i-elastic noma inelastic. Bazosho mhlawumbe ukuthi isho ukuthi i-collision i-elastic noma inelastic, and then bethi give a reason for your answer, noma mhlambe show up by calculation ukuthi i-collision i-elastic noma inelastic. Kujwayele ukuthi kuba u4 marks or 5 marks. Mawukuthi u4 marks or 5 marks noma mhlambe ke 3 kanjena, kuzomela usebenzise i-calculation, uprove by calculation ukuthi i-collision elastic noma inelastic. But if ku-2 marks usho by words, so use ama-words uku-explain if ku-2 marks. Okay, kuma-words ke, let's say i-collision i-elastic, uzothi wena elastic collision, uzothi elastic collision, bese uthini ke i-reason yakho uzothi there was no loss in kinetic energy, bese uthi comma due to objects separating after the collision. Angazi noma niyangithola. There was no loss. Ayikho into ebaluleke kakhulu le, because that's how you define very elastic collision, which is a collision in which kinetic energy is conserved. So there was no loss in kinetic energy. But ubone ngani ukuthi there was no loss? Ubone ngokuthi ama-objects separate after the collision. So uzothi there was no loss in kinetic energy due to objects separating after the collision. Angazi noma niyayithola leyo nto. 2 marks ku-1 wala, 1 wala. And then in elastic collision, let's say collision inelastic, uzosho ukuthi wena inelastic, if u explain mhlawumbe bathi explain for 2 marks, uzosho inelastic collision 1 mark okusho ushilo ukuthi inelastic, and then i-reason uzothini, kinetic energy is not conserved due to objects moving together, noma due to objects moving as a unit after the collision. Na into ebalekile eshoyo ukuthi kahle kahle inelastic collision, i-collision ekanjani, i-collision lapho khona i-kinetic energy ngekho conserved. So uzothi because kinetic energy is not conserved, ubone ngani ukuthi ayikho conserved? Due to objects not moving together, sorry, due to objects moving as a unit after the collision. I hope niyayithola leyo nto le. Awukwazi ukukhuluma ngalento kuphela, ungakhulumi nge-kinetic energy, because i-definition ye-elastic ikhuluma nge-kinetic energy, i-definition ye-inelastic futhi ikhuluma nge-kinetic energy. I hope niyayithola. Into enza ukuthi kuyenzeka uthole ukuthi ama-objects amove together, but mhlambe ama-calculations asuggest ukuthi elastic. Kusho ukuthi leyo collision leyo ibingekho perfectly inelastic. Ngokwenu-ke kodwa la e-high school indlela esiyifunda ngayo ukuthi mawuchaza ngama-words uzosebenzisa yona lento engiqeda ukuyi-explaina la. But mawenza ngama-calculations awukwazi ukuwaphikisa ama-calculations nanoma ngabe i-scenario isuggest ukuthi ama-objects ahambe together. I-calculation mayithi elastic kuzomela ukuthi elastic, mayithi inelastic i-calculation kuzomela ukuthi inelastic. Kuyakuphoqa ngoba i-calculation isuggeste leyo nto le. Okay, usolva kanjani, uprova kanjani-ke by calculation? Ma uzosebenzisa i-calculation kusho ukuthi uzodinga ama-values and awuzuqala nge-conclusion, uzoqala uperform i-calculation uzothi sigma ek before. Konje sigma ek before uthini? Uthi 1/2 mv squared, iformula le-kinetic energy, plus 1/2 mv squared, iformula le-kinetic energy. So object 1 initial of 1 ngoba sithi before, object 2 initial of 2. Bese wenza substitution-ke la ufake i-mass ufake initial of 1 ungamkhohlwa squared, wenza substitution ufake u-mass ufake initial of 2 ungamkhohlwa squared. Bese ushaya i-calculator uthola i-answer, i-energy is measured in joules. Bese uphinde uzocalculator futhi the sum of ek after manje. Kusho ukuthi uzothini? 1/2 mv squared plus 1/2 mv squared. U-object 1 final of 1, object 2 final of 2. Sithi 2 ngoba sithi final ngoba u-after. Bese wenza ini? I-substitution. Ufake i-mass ungayikhohlwa i-final velocity uthi squared. Ufake i-mass ufake i-final velocity ungamkhohlwa squared. Bese upress i-calculator uthole i-answer in joules. Bese mawuqedile ucompare i-answer le oyithole la nale answer le oyithole la. Mawukuthi lama-answer owu-2 ayafana, wenza le conclusion le mawukuthi ama-answer owatholile ayafana. Uzothi sigma ek before is equals to sigma ek after ngoba into oqeda ukuyi-observe leyo. Therefore, elastic collision. The collision is elastic. I hope niyayithola. If awafani, kusho ukuthi uzokwenza le conclusion le if awafani. If lama answer owu-2 awafani, uzokwenza le conclusion ethi sum of ek before is not equals the sum of kinetic energy after. Bese uthi therefore in elastic collision. Usoprovile yizo zokuthuna-ke indlela zokuprove ukuthi i-elastic collision noma i-inelastic. Uperform i-calculation noma use ama-words. I hope niyayithola. Njengoba yilokhu yishayisana-ke lezi moto lezi, njengoba ngikhulume ngey'moto ey'shayisanayo, leyo nto isithatha isise entweni okuthiwa i-impulse. I-impulse is just the product, now lo product usuyabuya, the product of the net force acting on an object and the time the net force acts on an object. Angazi noma iyezwakala leyo nto le. I-product ye-net force e-acta kwi-object nesikhathi i-net force e-acta ngaso kwi-object. So u-F net times delta t mathematical. But ngoba i-equation kune-equal sign asikhohliwe izoba equals to lo. So iformula le-impulse lithi iformula le-impulse lithi F net delta t equals change in p, change in momentum. Uzozwa-ke kakhulu bethi impulse is the change in momentum. Into ebaluleke kakhulu le ukuthi uyazi ukuthi impulse is the change in momentum. But that's not how you define the impulse. How you define the impulse, we define the product of the net force acting on an object and the time the net force acts on an object. But the impulse is the change in momentum. Okusho ukuthi ama-units we-impulse awuye u-kg meters per second ngoba i-change in momentum ama-units wayo awu-kg meters per second. But ama-units we-impulse futhi ayaba u-n, remember force is measured in n, and then u-s isikhathi is measured in seconds. So ayaba u-Newton second. Yiwo owu-2 lawa ama-units we-impulse. Kuzomele kuwazi. Uzobona ukuthi calculator kanjani impulse. But leli formula leli ungakwazi ukucalculate ngayo i-force, ungakwazi ukucalculate ngayo isikhathi, ungakwazi ukucalculate ngayo i-change in momentum. Mawunayo i-change in momentum, unayo i-impulse ngoba impulse is the change in momentum. Kubaluleke kakhulu lokho ukuthi ukwazi. I hope niyayithola. So njengoba likanjena-ke iformula le-impulse siyavumelana ukuthi la singakwazi ukulu-expanda silithi ngoba i-change in momentum ilento le kahle kahle. So uma ucalculate i-impulse ungasebenzisa noma iliphi iside le-equation, ungasebenzisa leli noma leli, kuzodepend ukuthi bakunikeze yiphi information. Nayi into ebaluleke kakhulu uma ukuthi mhlambe u-object A lona uzoshayisana no-object B, mabe ngathi calculate momentum on A, ungakwazi ukuthatha izinto eka-B uyi-calculate. Nanoma bengathi calculate the momentum of A, ungakwazi futhi ukuthatha izinto eka-A uyisebenzise ukuthi uthathe ikabani. Kanjalo mabethi calculate the impulse at B, ungakwazi ukuthatha izinto eka-A uyisebenzisa kunankinga. Mabethi calculate the impulse at B, ungakwazi futhi ukuthatha ezakhe u-B lowo. Kanjalo ne-force, mabe ngathi calculate i-force e-exertwe u-A ku-B, ungathatha izinto eka-B uyisebenzise, ungathatha izinto eka-A uyisebenzisa kunankinga. Nanoma bathi calculate i-force e-exertwe u-B ku-A, ungathatha eka-B uyisebenzise, eka-A uyisebenzise ukuthi usebenzisa ziphi. Why? Mawubheka i-impulse ithatha i-force nesikhathi. I-force on object A izofana ne-on object B by u-A, A by B, B on A by B, on B by A. Angazi noma niyayithola leyo nto le. U-Newton third law osuke esho leyo nto ukuthi u-object 1 may exert i-force ku-object 2, no-2 zo-exert i-force elinganayo ku-1 in opposite direction. That's why ngithi mawukuthi bathi calculate i-force, ungasebenzisa noma yimuphi phakathi ka-A no-B. Mawuthanda ungasebenzisa u-A, mawuthanda ungasebenzisa izinto eka-B, kukuwe i-force izofana as long as nje ubhala i-direction e-right ekugcineni. Kanjalo-ke ne-impulse. Leyo nto le ibalekile even nakwi-multiple choice bayabuza ukuthi bekunikeza ama-mass bekudide ngama-mass bese bebuza ukuthi impulse ka-A ku-B izoba greater than noma izoba equals to than impulse ka-B ku-A, kuzohlezi ku-equals to i-impulse ne-force nesikhathi, into eyi-1 leyo izohlezi equal. Angazi noma niyayithola leyo nto leyo, niyibheke kakhulu-ke leyo nto ibaluleke kakhulu. Okay, ithi siliconsider leli formula leli le-impulse. Formula le-impulse, remember sithi lithi F net delta T equals change in P. Uyabona uma ungadivide ngo-delta T ngapha nangapha uzogcina uthola iformula lithi F net equals change in P over change in T. Okay, ithi ngikubonise ukuthi leli formula leli siliderive kanjani. Let's consider u-Newton's second law. Newton's second law uthi F net equals MA, Newton's second law mathematical. Siyazi kodwa ukuthi i-acceleration ine-formula kwayona, lithi delta V over delta T. U-delta V over delta T. But u-delta V siyazi is V final minus V initial. So it's mass and then V final minus V initial over delta T. I hope niyayithola leyo nto le. Yini le ngiqeda ukuyithola la kwi-numerator yami? Change in momentum. Formula le change in momentum leya. So ngine change in momentum over change in T equals F net. U-Newton's second law lo. ayikho into engiyi-add la ayikho engiyikhiphile ngishintshile nje nga-reveala ukuthi acceleration kanje. So this is Newton's second law, but in terms of momentum. This is just Newton's second law. This is Newton's second law in terms of momentum. Ngoba sesiyiveze i-Newton's second law hayi kanje but kanje sekune momentum phakathi. I hope niyayithola leyo nto. Yilo leli formula leli engikhuluma ngalo le Newton's second law in terms of momentum. Nayi into okumele uyazi kwi-science. Mawukuthi unento kanjena kune-relationship la between A no B. I-relationship between A no B ithi A mayikhuphuka no B uzokhuphuka. Mawukuthi unento kanjena kune-relationship between A no C. Isho ukuthi u-A mayikhuphuka u-C uzokwehla. So lana i-relationship sithi directly proportional, i-relationship la sithi inversely proportional. Kuyenzeka kodwa kuyo futhi science lesikhuluma ngayo uthola ukuthi sinento kanjena bese ithi yena u-A mayikhuphuka u-C uzokwehla at the same B, uthole lona uzoremaina the same. Niyibheke izinto ey'kanjalo njengakhona la ku-Newton's second law in terms of momentum. Newton's second law in terms of momentum njengoba ikanjena u-F net mayikhuphuka u-delta T uzokwehla, u-F net mayehla u-delta T uzokhuphuka at the same change in P, at the same change in P. I-relationship kanjalo-ke la. Ine-application-ke Newton's second law in terms of momentum, but kubalulekile nokuthi ukwazi ukuyi-state. Uma uyi-state uthi the net force acting on an object is equal to the rate of change of momentum of an object in the direction of the net force. Uyi-state kanjalo. Application yakhona-ke into enjengama-airbags. Niyawazi ama-airbags asey'motweni ama-airbags. I-airbag lento yenza ukuthi mawukuthi kuyashayisana iy'moto noma imoto iyashayiseka ube protected. So kahle ngokomthetho wona kumele ngabe uyahamba uyoshayisa kwi-windscreen noma kwi-steering wheel. I-airbag izozama ukuthini ukudileya leyo process le. I-airbag kuba into eyibhalloon enomoya. So wena uzobe uhamba against umoya, ibhalloon nomoya, ibhalloon nomoya uzofika kwi-steering wheel usungasayi ngespeed esikhulu. Noma ufike ku-windscreen usungasayi ngespeed esikhulu. Kusho ukuthi in other words by having i-airbag noma i-airbag umsebenzi wayo in that case ukuthi uthenga isikhathi. So isikhathi sizo-increase so that i-force ozoyi-experience izoba ncane. I hope niyayithola leyo nto leyo. So i-airbag nje umsebenzi wayo is to increase the time of contact. Njengoba ngisho ukuthi akufani ukuthi makwenzeka ingozi makungena airbag uzovela usuke nje straight uyoshayisa ku-windscreen, but if kwenzeka ingozi and then i-airbag iyaphuma iyafutheka uzoqala ulokhu uya against i-airbag uzokhanda ufika ku-windscreen, uthothi ufika ku-windscreen awusafiki nangespeed esikhulu bese ugcina unga-experience-anga i-force enkulu. So mawukuthi ulokhu uya kancane against umoya kusho ukuthi kuzokuthatha isikhathi esikhulu increase isikhathi. Kuzosithatha isikhathi eside ukuthi ufike ku-windscreen. Therefore i-force ozoyi-experience mawushayisa ku-windscreen izoba ncane noma ku-steering wheel. Enye ama-arrestor pads. Ama-arrestor pads ama-sand roads. Uyabona ukuthi i-main road mhlambe lena and then la eceleni kuzophuma esinye istrati sinenhlabathi le i-river sand. Benzela ukuthini kuba iy'trati ezehlelayo kakhulu ukuthi i-truck malithi liyahamba bese mhlawumbe liphelelwa ama-brake endaweni eyehlelayo lizokwazi ukuthi lingene ngapha lingene kule strad esiyi-sand and then lizolokhu li-slower down lize li-brake. So i-sand nayo yenze njani izama uku-increase i-time of contact so that i-force ezo-experience-wa izoba ncane. Enye example noma enye application ye-Newton's second law in terms of momentum mhlawumbe masingabheka i-cricket, angani ubhalwa nje i-sport i-cricket. Kwi-cricket khona umuntu okuthiwa u-wicket keeper. Nawo ama-stumps, khona into okuthiwa ama-stumps le abazama ukuyishaya ngebhola. Khona umuntu omile lana ophethe into eyinduku i-bat ufuna ukuthi ibhola maliza elishaye liyele kude. Kuyenzeka kodwa eligeja. Mayiligeja khona umuntu ola ngemuva olindile ukuthi ibhola mayiligejile lona yena elibambe. Ukubizwa nge-wicket keeper lo muntu lo. I-wicket keeper ke ayivele ime nje imise izandla straight bese lifeyila yashaya ibhola ba ayenzeki leyo nto leyo. But i-wicket keeper into eyenzayo iyama bese malifika ibhola bese i-shiftisa izandla izisemuva while ibhola lihlala ezandleni izisemuva bese iqedile ukuhlala bese iyalibamba-ke kahle. Kusho ukuthini yenzani? Izama uku-increase i-time of contact mayenza kanjalo i-wicket keeper so that ibhola lingeze ukudala i-impact enkulu ezandleni so that ingeze ukuzwa ubuhlungu. So yenze njani i-wicket keeper i-increase i-time of contact so that i-force izokwehla. Kufana nanoma bekushaya esikoleni, angazi noma nisashawa yini ey'koleni, but mawushawa esikoleni bezokushaya ngenduku esandleni wenze njani? Awusimisi nje straight isandla, mhlawumbe nokunothisa abanye abantu bajwayele ukuyenza leyo nto. Awusimisi nje straight isandla but uyasimisa and then mayifika induku bese kuba ngathi usishonisa phansi isandla. Usuke wenzani? Hhayi ukuthi uyasisusa isandla ukuthi uthisha ngeke eze kushaya. No, uzokushaya but usishonisa phansi. Kusho ukuthi induku mayithi iyafika esandleni wena wehla nayo, induku wehla nayo. Uzama ukwenzani? Uku-increase ini i-time of contact. So ma-increase i-time of contact, u-F net uzokwenza njani? Uzokwehla. So uzo-experience ini? I-force encane ma u-increase i-time of contact. I hope niyayithola leyo nto leyo. Kufana nokuthi ngakuphosela labantu abaphoselana iy'tina, nokubabona basibamba isitini bevele beqondisa izandla but bahamba naso isitini basuke be-increase i-time of contact so that singeze ukubalimaza ezandleni isitini kanjalo. Nanoma ujumpa from phezu kwendlu, uma ujumpa from phezu kwendlu, i-application of Newton's second law in terms of momentum leyo. Uma ujumpa from phezu kwendlu ngeke usuke nje u-straight phezu kwendlu uzofike phansi ulende u-straight but uzosuka mhlawumbe u-straight phezu kwendlu bese mawufika phansi mawulenda on the ground uzogobisa amadolo. So mawugobisa amadolo usalenda until uqeda ukulenda bese uyama-ke straight. Usuke wenzani-ke? Uzama uku-increase i-time of contact by bending ama-knees so that the force experienced izoba reduced at the same change in momentum. Bheka la ngibhala u-delta T, u-delta P lo, at the same change in momentum. Iyo-ke i-momentum le i-chapter ngicabanga ukuthi ngikhulume ngayo yonke into bekumele ngikhulume ngayo. Engingakhulumanga ngayo uku-interpret ama-graphs. Ngizoyenza i-video uku-interpret ama-graphs mhlawumbe separate. Ngiyabonga. Ngibonga kakhulu nakulabo abasubscribe-ile. Ungakhohlwa ukungithinta for ama-online classes.